Okay, hello. My name's Idan Beck, and I will be leading us through an exploration of deep learning for games and simulation. So, this is a super exciting thing for me to be able to teach this course. This is a topics class, 797. It's a graduate level sort of exploration of these topics. And this first lecture, we're going to kind of go through the course, the structure, what we have planned for this semester, and kind of to talk a little bit about also the content of the course, but just to touch on it because one thing that's really important to me, and I'll kind of say this throughout the first few weeks of this course, it's really important for me that you all as students really kind of help me gauge the speed that we go through the material in, as well as the kind of material that we're going to then sort of explore, because this is a pretty small class. There's only a few of us, and this is more of a seminar type of class. And the goal is, while we will have assignments and the main focus of the class will really be around this project that we build, that really you guys build, I really want to kind of calibrate it to your goals, in the context of utilization of deep learning for games and real-time simulation type systems. So that's quite broad. A game could be a video game, like in the context of, like a first-person shooter or something like that, and applying AI and deep learning for things in literally for game applications. But a game could also be, and a real-time simulation could also be literally that simulation, or can we simulate how a particular environment will react given certain things, and can we use deep learning techniques to do that in a faster way than would be traditionally possible with heuristic search. So the class will start sort of at the bottom, just in the beginning. I'm not going to assume too much machine learning knowledge. But if you all have been exposed to a lot of these ideas already, you find that these things are kind of rote. I really want you all to sort of respond to me, and as you'll notice in kind of as I get into the course details, I'm going to try to make it as easy as possible for you to communicate with each other and with me, even though we're in this sort of asynchronous online format. And we're going to have very limited non-asynchronous components, except for the exception of one day, one moment at the end of the semester where we'll all sort of present to each other what we've been working on through the semester, and that will be done in a live fashion. But everything else will be completely asynchronous. Even sort of a mid of term like presentation that everyone will give will be done in a format like this. Like you'll record a video, or it doesn't have to be a video of you, but a presentation. And I'll kind of get into that as we get through this as well. So let's kind of jump in. So the subject of this class is really deep learning, for specifically for games and simulation. And we'll kind of talk more about why that's interesting a little bit in this lecture, and more so in the next lecture. So first off, what is machine learning? You may be asking yourself this if you haven't been exposed to it too much before. Maybe you have, maybe you've heard it, maybe you're interested in it. So what is machine learning? It's really simple. All machine learning are a set of algorithms, or a study of those algorithms, which have not been explicitly programmed to do a particular thing. And this is there's a lot of subtlety here, because some machine learning algorithms have definitely been developed to solve a task. I mean, otherwise, why would we even do those things? But the underlying mechanisms that power machine learning algorithms have not been explicitly programmed and designed for those tasks and to accomplish those things. And so what we kind of assume is that we build a thing that may not work so well, and then over time, using this concept of experience, which we've mentioned here in this slide, the system gets better and better at doing a particular thing, or accomplishing a particular goal, or executing a given task. And so you might ask yourself, well, what is experience, right? And you may sort of root this in your own personal intuition of your own experience, which is I walk to the store every day, and I've gotten really good at it because I know where it is, and that's a form of experience. I don't have to think about it anymore, right? But now consider the situation where you're walking to the store and all of a sudden your route has been changed because they're doing construction on the sidewalk, and your ability to then adapt to that change of environment based on what? Actually, on prior experience, because in other situations like that, you did this. And so experience can be a variety of different things. It can be either data that we're presented with in that moment. It could be data that we haven't ever seen, but we've been told about, and things like that. So this is a lot of nuance in the definition of experience here. And in the context of neural networks, which we'll be talking about more throughout this course, there's a relatively specific definition of this depending on what kind of sort of learning paradigm you're under, be it supervised, unsupervised, or reinforcement learning, which is kind of not specifically the same, but in a way, right, a very much a way to determine policies of behavior. So the underlying kind of term here, experience, really is just some kind of data, just some kind of thing that we can use to essentially learn from. And these algorithms in particular are not ones that are a bunch of if-else statements, right? They receive kind of this data from their environment or from the actual data sets they're trying to replicate, and they try to match patterns and then improve over time. So not the best definition and kind of hand wavy, but I think this particular aspect of machine learning is a little bit hand wavy because every algorithm has sort of different definition of what that is. And I think that's one of the exciting things about machine learning to me, is that this field is constantly changing and people are discovering almost new ways to manipulate these systems. And these systems are able to accomplish tasks that these tasks are no longer measured by yes or no, did we do the thing we wanted to do. These tasks are actually measured against human ability, or really kind of as a statistic of how often are we right, how often is this correct, how often can we recognize this as that. And these are much more fluffy, fuzzy kind of algorithms, and it's very kind of interesting to explore that right now, especially as we're kind of watching this revolution happen in terms of machine learning. So you might be asking yourself, is this AI? Is deep learning AI? Well, kind of, right? So to be a little bit more specific, AI can be accomplished in many different ways. Some of you have already studied AI, in particular with games. In other classes, for example, path search is a form of AI, making sense of how to get from point A to point B. And you can also kind of argue that any kind of application or program that can sort of make a rational decision is a form of AI, but that doesn't always mean that that's sort of what we're after with these sort of more fuzzy type of systems that can react to patterns and match things that maybe a traditional algorithm can't do. So machine learning is actually a subset of artificial intelligence, and deep learning is a further subset of machine learning. So there are, and we'll go through a few of these, there are plenty of non-deep learning machine learning algorithms. Like, for example, I'd assume every one of you has had experience with the normal equation method to solve a set of linear equations, right? So it's you basically create a matrix. I forget the form, I didn't look it up before this, but you basically take the matrix and invert it and then do the thing, and then you get the analytical solution to your set of linear equations. So you just set up the thing, you take the inverse, and you can directly solve for y. But that's technically machine learning too, I guess. In fact, it's considered a one-step machine learning algorithm because if you know all your data and then you effectively know the distribution, and you can actually calculate that. But if the data set's small enough, you can actually directly arrive to that solution. So you don't actually have to go deep. But in deep learning, we're going to talk about essentially multi-layer neural networks that are trying to approximate a very, very complicated probability distribution of some kind in a way that, say, sort of an affine linear transformation is going to be is not going to be very successful at doing that without a trivial amount of compute that makes it kind of impossible. So we'll talk more about this in the coming courses, coming lectures. But for the time being, you can kind of assume deep learning is a subset of machine learning, and which is a subset of artificial intelligence. Okay. Kind of got ahead of myself there. So yes, what is deep learning? It's a further subset of machine learning that utilizes multi-layered neural networks. But we'll talk about this more in the future lectures. So why is this relevant to games and simulation? Well, given these systems are able to sort of respond to complex patterns of data, to approximate very, very complex probability distributions, or just very, very complicated functions in general, you can imagine there's a lot of applications to games and simulation that may benefit from machine learning and deep learning techniques. For example, these systems can be utilized to solve really, really complicated problems that just are out of reach for traditional algorithms, such as a sort of hierarchical tree network or behavior tree may just never get to a sufficient level of capacity or capability when it comes to, say, a dogfighting, like a dogfighting simulation, right? I think everybody in this class has had that experience of playing a video game and finding that you kind of learn that one thing that the AI can't do in your game, and sort of you can kind of outsmart them. And bots are always kind of bot-like in their behavior. But utilizing these deep machine learning techniques, we can actually build systems that react to information much more like a human being would, based on prior experience, based on seeing a variety of different situations, some of which have been imagined, meaning simulated, or been provided from a different network that we didn't learn directly. And actually, recently, just a few days ago, it was the DARPA dogfight simulation challenge. Actually, the AI was able to beat a very, very high qualified F-16 pilot, and this was done through, from what I understand, reinforcement learning. Well, deep reinforcement learning, which is we'll get into more of this later in the next slide, in the next lecture. But reinforcement learning and sort of is a little bit different than traditional, like than supervised and unsupervised. But you can combine the two, which is usually done to sort of represent your situation. So, anyways, there's also this aspect of machine learning, and this is a bit more my opinion, so I should qualify this, that I believe that in the near-term future, machine learning will start to dominate the way that not just these tasks and specific implementations are done, but also the way that systems might be built. So, the first kind of demonstration of this was a neural Turing machine. And a neural Turing machine was essentially used a recurrent neural network to effectively model a Turing machine. And so you were able to, instead of programming this machine, you trained it to do a particular algorithm. So you program the algorithm, you generate the data, which is easy because you can compile that, get as much data as you want. Right? Say a sorting algorithm, we can do a lot of different permutations of sorting and provide the data to this neural Turing machine, which then learns that algorithm almost probabilistically. And then you can then take that same system and then apply it to different kinds of scenarios that it might not have seen. So say you take a very, very trivial example of this, right, is you take a sorting algorithm, you generate data from it, then you train a network to accomplish those tasks. And then say you've only trained it on a maximum of 20, 30 items in the sorting algorithm, and now you've done it, and now you take it and you extrapolate that to thousands or millions of items and see how the performance of that neural machine works. And yeah, it might have errors, and that's probably not something you really want to do with a sorting algorithm, right? But think about a task like an algorithm that's extremely complicated, such as pathfinding. For example, we want to we take a pathfinding algorithm and we use that to train a neural Turing machine, and we train it in a very small space, right? Say the space of a relative 20 by 20 matrix or something like that, like a grid-based, something like jump point search or something like that. Now we've trained that, and now we can then we can take that same algorithm, that same neural Turing machine, and put it in a scenario where it's no longer dealing with just a small amount of data, but a very, very large environment, right? And see how that works. And these are questions. This is not to say that there's an answer here. This is just sort of an active area of interest for me, and kind of the next step beyond neural Turing machines. I've seen of neural GPUs, and more recently there's a team out of NVIDIA that demonstrated the benefits of this by building essentially what's called GameGAN. And GameGAN actually learned Pac-Man, and then you could play Pac-Man using an entirely machine learning system. So what they did is they hooked Pac-Man into the input of this thing. This thing had 3 different neural systems. It had a dynamics engine, a generative adversarial network-like generator, and also a neural Turing machine for the purpose of long-term memory. We'll talk more about why that architecture makes sense. And over time, this learned the game, and then you could literally unplug Pac-Man and just play the game without any other thing plugged into it. So now the networks have essentially learned how to generate the next frame of the game. The dynamics understands how to then run that rendering front end, which is a learned rendering front end. And also the neural Turing machine is used to sort of maintain state, a long-term state, which, again, as we'll talk about in future lectures, machine learning algorithms are not great at maintaining long-term memory. And so you need to kind of come up with different systems for that. So, whoops, maybe you can't see that, but a little pop-up. Okay, so with that, let's jump into kind of the class overview and the things that we'll sort of talk about that. And again, like as I mentioned, this is the first time I've taught this class. The subject matter is going to be very fluid, and this is a very advanced, this is a graduate level or very advanced, undergrad class. We'll talk a little bit about the requirements and things like that. But I really want to make sure that you all get benefits out of this. And so feel free, again, to really, really encourage me and tell me what you like, what you don't like. If you want to go faster, if you want to dive into something even deeper, please feel free to talk about that. I'll talk about the mechanisms for doing that and how to communicate in the class soon. So here's the class overview, but I keep in mind it's up for debate, So we'll start off in supervised learning. And we'll start off really easy with linear and logistic regression. Some of you probably have already seen those. And we'll start to get into multi-layer perceptrons and convolutional network architectures and things like that. Then we'll kind of change gears and go into sort of unsupervised or self-supervised learning. We'll touch a little bit on like K nearest neighbor and just to talk about what the difference is between supervised and unsupervised, but quickly go into generative models and autoregressive models like pixel CNN and things like that. And then we'll, at the end, the last portion will be reinforcement learning and talking, again, to kind of introduce the reinforcement learning problem. We'll talk about K-armed bandits just to kind of talk about that, and then dive into MDPs, Markov decision processes, and then explore some of the deep learning approaches to solving the reinforcement learning problem. And the goal of going into reinforcement learning is less the reinforcement learning component of because reinforcement learning on its own is this whole thing. We're gonna skim that part, and instead we'll really jump straight to policy gradient, Q learning, and actor critic, which essentially, if I'm scaring you a little bit, keep in mind all we're talking about here is essentially applying supervised and unsupervised learning to the reinforcement learning problem. And reinforcement learning in this context, by the way, it really powers an agent that can make decisions in an environment. And I think that's really relevant to games, which is why it's sort of top of mind here. And I'll talk a little bit about myself in a minute, but no, there's a lot of different ways for us to approach these things. In particular, Unity, for example, with the reinforcement learning side of things, has an AI agent, the ML agent framework, which is one of the top reinforcement learning frameworks from researchers and engineers out there. And I happen to work at Unity, and I happen to work on that team as well. So we have a lot of resources there to kind of pull from. Oops, here. Cool, so a little bit about me. I'm kind of a wild card serial entrepreneur, which means I haven't been successful in a massive way quite yet, but it's been a lot of fun. So I haven't really had many full-time jobs. In fact, this Unity job that I just got as a result of the COVID pandemic, which I'll talk about how I got there, is my first real job in like 10 years, basically since college. So now you know how old I am. Great. So a few years ago, during my last startup, I was bitten by the AI machine learning bug. I kind of talked a little bit about this already. I'm happy to go deeper into it. But I believe that fundamentally, a lot of systems will start to move in this direction of machine learning. I actually believe if you're not learning or actively kind of pushing in this direction right now, you're just going to be left behind. Because imagine that example I gave you of GameGAN. You've got a neural Turing machine plugged into a generative adversarial network that's replacing your rendering pipeline, and you've got a dynamics engine, which is also a machine learning system, a deep learning network. You don't actually really need to program those things. You need to know how to build them, and you need to know how to connect them. But this is very different than, say, building a graphics engine, right? And thinking about where does the camera go and how many objects and creating a quad tree and all these things. Although the concepts are very much valid when you're designing these systems, as we'll find out as we study some of these more interesting research papers that in this course, right? You do need to understand what is a quad tree and how do I get a machine learning network to think about a quad tree and reason about the quad tree and sort of try to replicate the quad tree. So you're almost like trying to train these networks to understand these concepts, right? Versus building them bit by bit. And you can kind of hear, right? This is the difference between landscaping and planting a little bit like a seed every single place you want it to grow and then watering it perfectly. Right now, engineering is largely kind of that latter case where I'm going to put things exactly where I want them and hit compile and it runs. And if one bit's off, then everything blows up. But machine learning kind of ushering in this new era where instead of designing these algorithms explicitly, it's almost like I'm planning the city. I'm like a city planner, and I say, okay, I want the houses to be here and whatever. It's almost like playing SimCity, and then over time, emergent behavior kind of arises, and we see what happens, and we kind of are catering it, and we're trying to like nudge it in the direction that we want it to go. And then over time, we kind of correct the error between what we want and what is currently. And over time, that leads our city to behave the way we want it to behave. And all of a sudden, now we have an algorithm that can do things and be dynamic in them in a way that a traditional algorithm just can't, do those things. So just a little bit more about me. So I'm currently at Unity. I'm there to explore kind of the intersection of machine learning and graphics, specifically in the perception team, which we'll talk about what perception is as we go along. I'm also an adjunct at RIT, as you know. I'm teaching graphics and simulation, and now machine learning and AI, which I'm very, very excited about. So a little bit about the stuff I built. So here's a bunch of my startups that I've done in the recent past. Here's stuff that I've helped work on. So I was CTO of Sandbox VR. I was at EVA Automation, which was acquired by Bowers & Wilkins. I helped Yamaha. I'm a mentor for Hacks and Brink. And I've also helped start a company called Hackster, which was acquired by Evnet in 2016. So this is the stuff that I'm really interested in particular, generative adversarial networks. In fact, the example here is really these, pix-to-pix and conditional GANs, as well as cycle GAN, which we'll talk about all of these papers in this course. So to talk a little bit about the resources that we have in the course and the way that we're going to run this class. So now this is the boring part, I know, but hopefully we'll get through this part relatively quickly. And keep in mind, I'm going to keep these lectures topic specific. So I'm not going to do, okay, we need 30 minutes, 45 minutes a week or whatever bullshit. I'm going to talk to length on a particular topic, talk to length on, if I'm building something or writing code or whatever, we're doing a demo, whatever it might be. So keep that in mind, that the goal here is not to just fill up the hours. This is a graduate level course. The point is the focus is on the content, on your hopefully respective passions for the subject and for your degree, and if you're doing research. So that's the goal of this class, is to really enable you all to kind of pursue those things as well as myself in teaching it. So here's my email, IXBigM. Whoops, please don't use my email unless you really have to. I'm a busy person. I'm not a full-time professor. So email's like the last resort. If you think I'm dead, email me and then I'll probably respond. Better to find me on Discord. So this is the Discord, my Discord where I, host channels for classes that I teach. if you go to this Discord, you will find a IGME 797 channel there. So please make use of that and communicate with me, communicate with other students in the class. There's not going to be that many of us, and so it's hopefully going to be a very effective way to communicate. I'm going to make myself available for office hours using this link here. I'll talk about all these things kind of as we go throughout the lecture. Also, I'll be hosting all resources on Notion. I will be mirroring certain things to my courses, but Notion will allow me to link a lot of the research papers more easily that I'm currently reading, that I'm exploring, as well as kind of create the content and resources for this course much more rapidly and more iteratively than would be possible with my courses. So my courses will use to kind of keep track of things. I'll post lectures on there, as applicable. But if you want the most up-to-date stuff, including the syllabus, including the rundown, the lectures, everything, here's the Notion link. Just click that and it'll take you there. It's public. If anybody has issues accessing this, please let me know. I've also pinned all of these resources to the Discord channel. I've also included my reading list. This reading list is sort of an ongoing track of all the papers that I'm reading and the exploration that I've been doing. It's a relatively recent thing I've been doing over the last, just few weeks, and so you'll find a lot of papers on there. And it's a really good place, as we'll talk about the project of this class. If you don't have any great ideas of what you want to do, this is a good place to sort of scour both my notes as well as just see paper. I mean, there's like 400 or 500 papers on there, and I've only read about 10% of them. So it's a good place for you to kind of get a feel for what's the state of the art, what's available, what's possible, and anything is fair game that I mentioned in these lectures. So yeah, so talking about lectures, I guarantee we'll have at least one lecture a week, although there may be more. Like I said, I'm going to split up lectures based on content, not on length. I've also got a couple of really exciting guest lectures lined up. They're not going to be confirmed until they're actually confirmed. But for example, the CTO of realities.io may do a guest lecture. He's in particular interested in the implicit representation of three-dimensional content. So there's a lot of really cool machine learning research around basically taking a bunch of pictures of something and then turning that into a 3D model. So he's super into that and may talk about that. I've got a couple of PhD students over at Berkeley who are that are working under some great researchers in the field that might do some guest lectures, as well as friends who are doing stealth startups that I can't talk about unless they come on and do a guest lecture, and I hope that they do. So there's going to be some cool stuff, and I'll be bringing in my network, maybe even people from Unity to come in and do a guest lecture as applicable. So if you have any requests, if you're like, oh, I really want to hear this company talk about what they're doing, let me know, and I might be able to set that up as well. So assignments, we're going to have 3 assignments. They're going to be each worth about 10%. I really sort of recommend that the deadline that you use for these assignments is 2 weeks within sort of when I release the assignment. I'll talk about this more, but I'm not going to hold anybody to any kind of late deadline bullshit. You guys are all responsible for your own time. I'm assuming you guys will get the work done when you need to, and if you need to be late, you need to be late. I'm not going to do if it's a minute late, it's 0%. No, I'm going to accept it whenever, with the exception of a couple of things that are time-based, but we'll talk about those. But yeah, my recommendation is finish the assignments within 2 weeks of them being released, just because otherwise I think you'll go crazy. So we'll talk about this framework called Epoch that you can use for the assignments. I recommend using Epoch, and by recommend, I really hope you do. But with that said, you're free to use whatever tools, whatever frameworks, whatever things you want to do the assignments. And another thing about assignments, so again, the focus of this class is really this sort of semester project where you're building something with deep learning techniques. And if you wish to change the assignment, you're saying, hey, okay, cool, I'm going to keep it within, say, as I mentioned, we're going to have 3 different assignments, one on supervised, unsupervised, and then reinforcement learning. So as long as it's within that topic and you say, actually, I want to do this thing, I want to implement this, and you kind of run it by me and I'll give you the thumbs up, and that's fine. So if instead you want to kind of make every assignment related to your final, to the project, awesome. I'll be very happy to support that. Just run it by me, talk to me about it. It can be just a Discord chat or whatever. You don't have to just do the thing. This is not the point of this class. Is not these assignments, but I do want them to be worth some amount of your grade to just make sure that they get done. So like I mentioned, the focus is the project. So you guys can team up if you want. I don't want to encourage you to group up unless you all happen to be interested in the same thing. So really, each student will sort of be measured, graded, evaluated independently. So this is not meant to be a group project, but if you all happen to be really interested in, I don't know, synthetic asset generation, you guys are, okay, I want to do, so you guys can all work on that together, fine. But keep in mind, right, we will have this topic presentation, which I'll talk about in the mid-semester. Each person has to give a unique presentation on a topic, ideally related to the project, so you'll kind of have to figure out who covers what. But again, just my recommendation here is there's no preference to single student teams versus multi-student teams. My hope and urge, I really urge you all to sort of do this based on what you're interested in. So if you're really excited about a particular topic, do that instead of ask each other. Oh, so have a conversation in the Discord or with each other at some time to see what everybody's interested in. Again, this is meant to be a very collaborative type of class. I'm not gonna, whatever, you guys can work on things together. It's fine. But in terms of the project itself, I really hope you commit to the project you want to do, not just sort of work with other people for the benefit of being on a team. Because as I mentioned, in this slide, I will expect a much more depth from multi-student teams versus one person, right? I'm hoping you all take this opportunity in this course to really explore and build out your knowledge of deep learning, which is a very quickly moving domain. And so, yeah, enough about that. So one sort of optional, I do encourage you all to do this, but it's sort of optional. The first sort of milestone of the project will be a proposal, or a topic project and topic proposal. This is optional. I recommend you do it because this will give me an opportunity to give you feedback, to say, oh, this is too hard, this is too easy, just kind of work with you on it. And I'll say when kind of the intended deadline for this is. And this is only going to have a deadline because if I don't want to wait forever, right? I think by, say, like the 4th or 5th week of class, you should know what you're working on. And so if you want to do it sooner, great. If you want to do it later, great, just say so. But I will provide a sort of measurement, like a suggestion, because obviously the topic proposal will be on a set date. And so what's the point of doing the topic presentation will be on a set date. So what's the point of doing a proposal after the presentation and stuff like that, right? So one exception here. So I know we've got a couple of graduate students in the class. If you're doing research in this field and you sort of want this class to be a part of your research or part of your degree and thesis, that's fine. That's what I did when I was in undergraduate school. So, if you want to do that, but just please talk to me about it. And so for you people that are in masters and PhD and what have you, this is not optional, right? I really need to understand how the work with this class kind of fits into your research or your thesis. Please don't treat that as a heavy-handed thing. I'm not going to be too harsh about it, but I just want to understand that there is sort of a unique aspect of the work that's being done for this course versus for the thesis. So it's not just you working on your thesis and then presenting your thesis as the project in the course. Although if there's a lot of overlap and they work together, that's fine. And I'm happy to share my own thesis and my own stuff if you're interested in what that distinction looks like, and if you're nervous about it. Cool. So the topics presentation, it'll be worth 20% of the final grade. Like I mentioned, every student has to present a unique topics presentation. This will be mid-semester. It will, I'm hoping it's like 10 minutes long minimum. It can be as long as you want, but I want there to be substantial content here. And so think about it this way. Everybody else is going to see your presentation. I'm going to post them just like these lectures. And so every other student hopefully will learn something from your presentation. And so my hope is that you choose a topic that's related to your project that you're excited about, and then you can teach us all something very exciting and interesting about it. And so these will be submitted. You can do it like the way I'm doing it now. I'm using Loom. You can also use OBS, or you can just do video. You can also just do audio. You don't have to do a video if you're not comfortable. That's fine. But make some slides and do a voiceover. That's okay too. But yeah, it's got to be like a video submission, and so it's not going to be live or anything like that. So you can feel free to edit it, do whatever you want. So the topics presentation can be literally just present a paper, right? Okay, here's a paper that's related to what you want to do. You talk about it. That's great. It can be about your project and what you intend to do, and kind of teach us all about what you're looking to do. And again, but like keep in mind, like there should be something substantial here in terms of learning something. And again, this is why I recommend you all do the proposal, because I think that will lead to a much better outcome here than would be otherwise the case. Again, if there's any questions about this, all right, this is actually going to be instead of a midterm. So there are not going to be any real formal tests in this class. It's basically going to be assignments, topics presentation, final project presentation, and submission. That's it. So that's going to be hopefully a nice thing. But with that said, like think of this as the midterm. It is meant to be like a demonstration of your knowledge, not just, hey, I'm working on this project, you guys check it out. So the final project presentation, I've kind of purposefully made it a relatively small amount. I just want to make sure we do it, so it's worth 10%. And in this context, you can do this as a group. So if you do multiple people, if you are in a group, then there's only one presentation per project. And we'll present this in a webinar style. And so we'll choose, this is going to be the only non-asynchronous aspect of this course. We'll sort of find a time that works for everybody in the last sort of 10 days of classes that, and we'll schedule that and we'll all show up. It'll be like a Zoom or whatever virtual thing, so you don't have to go anywhere. I'm based in California, just so you all know, so it's not even possible. And we'll have this live sort of presentation. Maybe even I'll present something, and it'll be fun, and it'll be kind of the end of the class. We'll all get to see what we're doing. This last bit was not deleted. Ignore the last section here. I'll edit this. I'll edit this afterwards in the slides, but it's the project presentation should obviously be about your project, and it should be demoing your project in whatever, if the demo is applicable. And yeah, but it's only going to be 10%. It's going to be the last week of class. And just keep in mind that the submission, the project itself, is going to be worth the substantial portion of the grade. And if you think about it, topics, the final project presentation, and the submission, right, we're talking like 70% of the grade is going to be related to this project, minus the 30% of the assignments. So yeah, the final is really the point. And I will provide kind of a rubric or a suggested rubric for this if you're kind of worried about this substantial portion. If you have any questions about this, please let me know. Just know I'm happy to tell you sort of how I feel you're doing at any given moment. You can check in with me. This is a small class. Again, it's like a seminar type of thing. It's very intimate, so don't hesitate. But just to kind of talk about logistics of the final project, the deadlines will actually be the last to second day of the second to last day of finals. So I'm giving you as long as you possibly can have, but I do need like a day or two to get grades submitted to RIT. I don't want to do it like to the last minute. So yeah, the presentation and the submission are two separate events. So the final project should include a report, the all working code and respective relative work that's been done, a demo video if that's what you're going to be demoing. I'm assuming this is for games and simulation. It might be a interactive thing, whatever it might be. It's up to you what the demo is, be it a video, be it a picture, be it a whatever it is, and all resources as applicable. So yeah, just make sure that the work is the focus here. I do recommend for the report to kind of try to replicate the research papers that we're reading. Right, there's just a great template, a great approach that people use, and you can use latex and make LaTeX or whatever it's pronounced. It's up to you. I'm not going to really care that much. I really care about the content. But if I'm going to encourage one thing, it's that, like make it look nice. You're going to feel better about it, And hey, like, a lot of really interesting research papers have come out of classes like this, where a couple of students work on a cool project or idea during a semester, see some surprisingly good results, and then go and kind of keep working on it, and then eventually release it as a proper research paper. And you'd be surprised how many of the research papers we're going to talk about in this class were made by just students in a class somewhere. So this is sort of an early days for this field, surprisingly. And so I do encourage you to just, like, it's not going to be publishable if you don't think about it as such. So treat it seriously, and maybe it will become something. I'm not suggesting that's the goal of this class, but hey, why not? So office hours, they're available by request. I have a Calendly link. You can click here. You can see available time slots. I'm a busy person, unfortunately. So if you just ask me the day before, like, hey, can you jump on a call tomorrow for an hour? I'm going to be like, probably not. But, I'm going to do my best. So keep in mind, the Calendly is a good way to get on my calendar for 15 minutes, like, very quickly. Alternatively, if you need more time, if you need something deeper, if the times available in the Calendly don't work for you, again, just ping me on Discord. We'll find a good time. We'll figure it out. Like I said, there's only a few of us in this class, so feel free to just reach out to me directly. Oh, and I didn't mention this before. So my name's Idan Beck. Do not call me Professor Beck. Just call me Idan. It's okay. We're all friends. Please don't treat me so. I know that technically I get to choose what the grade is, but as you've seen, the focus of this class is the work and the study. And as long as you stick to that and you push and you do your best, like, I guarantee you'll do fine. And I'll be right there with you. Right? That this is actually the exciting thing about this, is that we're working together. Speaking of which, let me talk about the Epoch framework. So the Epoch framework is actually to build a framework for real-time AI and machine learning. I've been working on this for a few months. It hasn't gotten as much love in the last few months as I would have liked. You can kind of, if you look at the code today, it kind of looks like a cobbled together Vulkan C++ engine with sort of like custom STL classes and with the intention to integrate TensorFlow, although that hasn't been done yet. You don't have to use it, right? Most of the machine learning world is currently with Python and Jupyter and TensorFlow and PyTorch and Python. But I do recommend that you do use this because I will be actively developing on it. And if you do run into issues and you want to do something new, like, I will be there to try to solve those problems and to work on them with you. Whereas if you run into like issues with Jupyter and PyTorch, I'll be like, okay, well, go check the forum, because even if there's nothing I can change about PyTorch, I can maybe tell you how to fix your code, maybe, or something like that. But for the most part, it's going to be out of my hands. It's a publicly available framework. There's not much we can do there. So yeah, you can obviously use Jupyter PyTorch, Jupyter TensorFlow, whatever. But it's going to be, all grading will be done on an effort basis and a results basis, not specific to a rubric of like, oh, you didn't use this semicolon in the right place or whatever. So yeah, again, just to kind of touch on this again, use Epoch at my own risk. If you use it and it doesn't work, that's my fault. And so I will be there to try to help you with stuff. That doesn't mean to say if you use it and your code doesn't work, I'm going to fix your code. No, but if you're using it and there's something wacky going on, I will go in there and kind of figure out with you. So it's a new experimental framework. So, what's up? Grading. So like I mentioned, just to kind of recap, 10% per assignment. We'll have 3 assignments. We'll have a mid-semester topics presentation. The project is going to be worth the bulk at 40% and 10% for the final presentation. And just for, kicks, here's the grading scale. You probably already know it. So we're getting to the end of the presentation here, to the lecture. Participation late policy. So there is none. There's no participation policy. There's no late policy. I'm hoping you're in this class because you're genuinely interested in these subjects. If that's the case, right, I hope you watch the lectures. I hope you participate in discussions. I hope you do things on time. But this is a grad level course, guys. So if you don't do the work, you don't do the work. That's fine, whatever. Like, do it whenever. But but try to stick to the schedule I suggest, because otherwise, it'll be the day before the end of class, and you'll have to do 3 assignments in a proposal and the project, and I guarantee that's not going to go well. So, yeah, you guys are responsible people. So I'm giving you all the responsibility that you deserve. But yeah, I do encourage you to stick to the deadlines that I suggest. Except obviously for the hard deadlines, they're hard deadlines. Like topics presentation will have a hard deadline, and obviously the final presentation will have a hard deadline, as will the actual final project. But keep the deadline is literally like the last day of class. And so with assignments, I really do recommend that you should do it within a couple of weeks of it being assigned. But I'm not going to go and throw a fit if it's late. This is true for all students, so it's not an unfair thing to say, because anybody can do whatever they want. So yeah, that's it. I'm going to treat you guys like adults, and I expect the same in return. So that's it. The next lecture, we're going to talk about what is machine learning at kind of a deeper level, and explore a few things, and kind of make the distinction between unsupervised, supervised, and reinforcement learning. We will take a look at some applications of it as well, see what kind of tasks are possible, try to kind of poke at where the state of the art is specifically for some of the more game and simulation type of applications that we were talking about. My hope is to get that lecture out this week. But as you guys all know, California is literally on fire, and so I might be all over the place for these first few days of classes. And yeah, hope to see you on the Discord with any questions. Really looking forward to teaching this class with you all, and super excited for everything in this coming semester. So thanks for watching, and bye.